Hello, everyone, and thank you all for joining us. Today's webinar is Unrivaled Cure Speed and Excellent Aesthetics brings a new dimension to fast return to service in concrete flooring, and it's presented by Evonik. Your presenter today is Xing Zhang. She is a research director at Evonik Corporation, working in the crosslinkers business line within the resource efficiency segment. My name is Alex Payne with UL, and I'll be moderating today's webinar. Please send your questions to us by typing them in the questions box located on your screen. Our panelists will answer them at the end of the presentation, and we are recording today's event, so we will send you a link by email when it has been posted to our website. Now it is time to begin the presentation. Xing, would you like to begin?
Yes. Good morning, everyone. First of all, thanks, Alex, for the introduction, and thank you all for your interest in this webinar. Again, my name is Xing Zhang. I work for Evonik Corporation, and we are located in Allentown, Pennsylvania. So actually, previously, we were part of Air Product and Chemicals before being acquired by Evonik 2 years ago. So if you are buying, you were buying from Air Product before, nothing has changed. The product name and trademark has not changed, just the company name. So I'll start today's webinar by first, I'll give you a brief background and then talk about market drivers, and then I'll introduce Anquamine 720A as a solution for one-day flooring, and then I'll talk about primer performance and Topcoat properties, followed by one-day flooring performance, and then I close with a summary. So since we'll be talking about epoxies, especially waterborne epoxies, so I want to give you a brief introduction, like why we are using waterborne epoxies. So waterborne epoxy is an established technology. It offers a lot of competitive advantages over solvent-free and low VOC systems. For example, obviously because it's waterborne, so it's low to zero VOC and easy water cleanup, very high aesthetics, very fast dry time, and has an excellent adhesion to concrete substrates, and then also very good impact resistance and the best cost in use. So because of all these advantages, waterborne epoxies has been used in a wide range of applications. Here, just give you a few examples. Factory floorings. So factory floorings see a lot of heavy traffic and heavy equipment. Waterborne epoxy is very easy to apply and very easy to repair. So it's perfect for factory floors, and it has excellent mechanical properties, so we can withstand a lot of heavy equipment in factory floors. Waterborne epoxy has also been used, often used in electronic applications. Since a main epoxy reaction is an adduction reaction, so let's no byproduct involved. So waterborne epoxies, it's perfect for clean room application, clean room conditions in electronic applications. And for electronic application, static dissipation, usually it's a requirement. So waterborne epoxy can be easily formulated into ESD type of floorings. Because of its high durability and good overcoatability, often waterborne epoxies also used in parking deck. So how does the waterborne epoxy fit into the broader market trend? So market trend has driven new product innovation and new product development, with the end goal is to increase productivity. Here I'll list a few of the key market drivers for the coatings industry, especially for like concrete flooring. So first, it's enhance our product performance that could mean like a better looking floor or better UV stability, and fast return to service, improve productivity. That could mean that will requires much faster cure speed and cure at low temperature. So that will give you the applicator wider application windows, especially in the northern area when like deep in the fall or start early in the spring, and robust application that could mean less substrate prep, and then the coating can be applied at higher thickness. And the third driver, it's environmental. So it's environmental and user-friendly product, low VOC, solvent-free, and waterborne. So all this is driven by business all want to have increased lower cost, and increased productivity means lower cost. So one concept coming out of the increased productivity is of one-day flooring. So concrete flooring typically consists of minimum 2 layers. So you have a primer layer and a top coat. So for one-day flooring, primer is very critical. Primer needs to dry fast and fast cure. So the top coat can be applied by the same shift and same crew, and the floor can be ready to service in one day. So why one-day flooring? What are the benefits? The benefits are multiple. To applicators that could they can apply 2 coats in one day and move on to their next job. And for end users and business owners, that means minimum downtime and fast return to service. So what are the key requirements for the one-day flooring system? So for one-day flooring, the requirement, there will be requirement for primer and top coat. So for primer, it needs to be fast cure and also like cure at low temperature. So the straw model we get from our customer voice is primer needs to dry like within 3 to 4 hours at 10 C and high humidity, and should have excellent adhesion to concrete substrate and good carbonation resistance to ensure intercoat adhesion to the top coats or the mid-coat. So I'll talk about carbonation resistance a little bit later in more detail. And the requirement for top coat is different. So it would be good aesthetics. So I'll emphasize this later. So in this section, I will focus on the primer performance. So what are the available fast cure technology in the market that could potentially mean the one-day flooring? So we have looked into the solvent-free system and the waterborne system. These are all known fast cure commercially available system that could potentially be used for primer. So for solvent-free system, manic base usually it's a typical go-to system for fast cure. And we evaluate all these systems on wet and dry concrete. So when I mean like wet and dry concrete, concrete is a very porous substrate. So dry concrete is a concrete we don't intentionally expose to water, and wet concrete, it's a concrete slab that being soaked in water for minimum 24 hours before being taken out for tests. So wet concrete usually contains about 3 to 4% of our moisture, and then dry concrete has 1 to 2% of our moisture content. So let's look at a solvent-free manic base system first. On dry concrete, it dries hard dry in 8 hours, and on wet concrete, it takes longer to dry. So on both wet and dry concrete, so obviously the solvent-free manic base is too slow for 1 day to meet the primary requirement for one-day flooring. But for waterborne system, we look at 3 known fast cure system, and then they are all with solid resin dispersion. So SERD stands for solid resin dispersions. So we look at evaluate all these three systems at 10C. I mean, all these systems are evaluated at 10C. So for the waterborne systems, on dry concrete, looks like, you know, they could meet the requirement for primer. But then if we look at the adhesion, all the adhesions are very poor on dry concrete. And on wet concrete, all these systems actually dry much longer, almost double the dry time. So none of these commercially available fast systems deliver for 1 day for requirement. So since we can't find a commercial system, so we develop a new system. It's a waterborne system that based on Anquamine 720A. Anquamine 720A is a new curing waterborne epoxy curing agent that can be used in primer and at Topcoat. So they eliminate the inventory that you have to stock, you know, different curing agents for primer and for Topcoat. So the key feature of Anquamine 720A is in combination with solid resin dispersion AR555. Actually, it delivers ultra fast cure speed and good aesthetics under low temperature and high humidity. So the benefit is return to service the very next day at minimum downtime. So a little bit more detail about Anquamine 720A. It's a very low color aqueous solution in water, about 55% solid, has a medium viscosity, and use level with the solid resin dispersion AR555, it's about 34. So Anquamine 720A, it's based on a proprietary neoamine technology that give the very fast cure speed. So next, I'm going to show you the starting point of formulation of the floor system based on Anquamine 720A. So for primer, it's based on solid resin dispersion AR555, and then the top coat actually it's on using the standard dilute epoxy resin. So it's 9010. You can see here it's 9010 standard bisphenol A type of resin with diluent. So why we're using liquid epoxy resin? So that will not only meet the speed requirement, but also most importantly, using liquid epoxy resin will cut down the cost for your entire floor system and will still meet for 1 day of flooring. So if we look at the primer formulation, primer it's a clear coat, just resin and curing agent with water at about 45% solid, and then the top coat it's a glossy white top coat at 55% solid. So since, as I mentioned in these slides, you know, we use solid resin dispersion AR555. So why? What's special about AR555? So AR5 compared to the conventional resin dispersion, AR555 has actually bimodal molecule weight distribution. So it has a low molecule weight portion and a high molecule weight portion. The low molecule weight portion provides self-coalescent. Therefore, AR555 does need a coalescing solvent to form a film. And conventional solid resin dispersion typically contains some type of coalescing solvent. And for the higher molecule weight peak of AR555, that give you a fast dry, just like a solid resin dispersion. So AR555 delivers not only the fast dry, but also because of this low molecular weight portion, it gives you excellent adhesion to substrate, like concrete substrate, just like a liquid epoxy resin. So that's the uniqueness of AR555. It's excellent dry speed and good adhesion. So we compare Anquamine 728 performance with AR555 and standard solid resin dispersion and on dry and wet concrete, and then these all are done at 10C. So most of the presentation, this webinar, we focused on 10C because that's the critical low temperature performance we focus on when we develop the product. So at 10C on dry concrete, the primer, Anquamine 728 primer dries in 2 hours. On wet concrete, just slightly longer, it's 3 hours, and then has very good adhesion to concrete substrate. And if we look at a conventional solid resin dispersion on dry concrete, it dries very fast, within 2 hours. But the adhesion, it's rather poor, so it doesn't quite stick to the substrate. And on wet concrete, the dry time, it's not only much longer, but the adhesion, it's rather poor. So this slide shows that Anquamine 728 primer has very fast cure speed and good adhesion to concrete substrate. And what about the other properties of this primer? So we just represent some of the data. So on dry concrete, actually, like at 10C and 23C, the temperature doesn't show any effect on the dry speed, and then the primer has a thin film set time within 1 hour. The primer also has a very fast property build up within 1 day, and then going up to 7 days. That just shows the hardness build. In addition, these are the other key properties of Anquamine 728 primer. It has excellent carbamation resistance. So here show a scale of carbamation resistance. Good carbamation resistance is a requirement for good intercoat adhesion to the top coat, since this is a primer. So carbamation, it's a test of amine salt formation on the coating surface. If there's any residual amine unreacting agents, amine that migrate to the surface, then it will react with moisture and carbon dioxide in the air to form carbamate salt. And then the salt will be actually shown as a white. So scale white, like scale 1, it's worse, a lot of salt formation, and then scale 5, it's excellent, that no obvious salt formation. So the primer here has excellent carbamation resistance and also show very high gloss. And then very importantly, it has a good adhesion to wet concrete substrate. In addition, one of the features of this primer is we can coat it in pretty thick coating in one pass. And it has a good overcoatability to epoxy and waterborne polyurethanes. We also look into the fast dry speed, like the impact of the coating thickness and humidity of on the dry speed. So on the left-hand side chart shows the thickness variance from about 15 wet mil to 23 wet mil. That's the dry time lengthy from 2 hours to 4 hours, not too much, but it's still within the critical requirement for a fast dry primer, and then these are all done at 10 degrees Celsius. And high humidity doesn't have a huge impact either. So again, it's from 2 hours to 4 hours, even at very high humidities, up to 85% relative humidity. So far, I have shown you that the Anquamine 720A primer meets the requirement, fast dry requirement, and also have good carbamation resistance and excellent adhesion to substrate. So what about the top coats? So for a floor system, you need a primer and a top coat. So what are the requirements for top coats? So for the top coat, in order to meet a 1 day or floor system, obviously it also has to be fast cure, but it doesn't have to be as fast or as primer, because top coat within 24 hours, you still have enough time for the primer to dry. So at 10C, as long as it's dry within 16 hours, it can mean 1 day flooring system, and should have good adhesion to the primer and also have good aesthetics. So here I'm going to show you the fast dry top coat and then fast property build up. So for the top coat, as I emphasized in the starting point formulation, that the top coat is based on dilute liquid epoxy resin. So the top coat dries like it has a thin film dry time at 5C, at 10C for 5 hours, and then has a dry hard time at 10C for 12 hours, and then it has a pretty good property buildup within at 10C and ambient temperature. Also, very importantly, obviously, it's the intercoat adhesion between the primer and the top coat. So that's the primer and then the top coat. So the intercoat adhesion, it's very, very good. So these are the fast dry. The primer meets the fast dry and good intercoat adhesion. What about the aesthetics? So next, I'm going to show you the good aesthetics of the top coat. So Anquamine 720A top coat has excellent carbamation resistance of a scale of 5 at 10 degrees Celsius, and then it's glossy over 90 at 60-degree angle. Also, it has a very good stability over part life and good UV stability. So we ran the accelerate UV test looking at the delta E before and after the UV exposure. So we compare Anquamine 720A top coat with a low emission solvent-free system, and also benchmark against another waterborne system. These are all known to be to exhibit like excellent UV resistance. So from this test, you can see that Anquamine 720A outperform solvent-free system, and it has a slightly better UV resistance than benchmark waterborne epoxies. So it definitely has a very good UV stability. Also, it does not show any pigment flocculation within part life. So within like 90 minutes, we compare Anquamine 720A with a solvent-free system. Solvent-free system definitely shows some color drift within 90 minutes, and Anquamine 720A top coat show very consistent color. So now up to this point, you have seen the top coat performance, the primer performance, and then the top coat performance. So how about we put a floor system together? How does it perform? So we look at a floor system at ambient temperature on dry concrete, and then extreme condition of low temperature on wet concrete. So you can see the frost system at ambient temperature can be back to service within 10 hours. And then on the extreme condition, that it can still be returned to service within 24 hours. So the frost system definitely show good aesthetics, excellent adhesion to concrete substrate, and good intercoat adhesion, and it's ready to return to service within 24 hours. So in summary, you can see that Anquamine 728, it's a unique solution for one-day frost system. So it delivers a fast cure, as this just to refresh what I showed you before. That it one day for you need a primer and a top coat. So the primer, Anquamine 728 system means fast dry, good carbon emission resistant, and excellent adhesion to concrete substrate. And then the top coat shows very good aesthetics, good UV stability, and minimum pigment for creation carbon emission resistance. So that concludes this webinar. So if you have any questions or would like to learn more about this technology, you can either email me or stop. Actually, I will be at the waterborne symposium in New Orleans in like less than 2 weeks. So you can stop by if you happen to be there. Stop by, ask me questions, and check out our other technologies. And I also will be presenting a paper on moisture vapor barrier in New Orleans. So stop by if you happen to be down in New Orleans. And then lastly, I'll be happy to take any questions you may have. Thank you very much for your attention.
Thank you, Xing. I can help moderate some of the questions that have come in. First one is a question from Jennifer that asks, what is the working time of the primer and top coat?
So for primer based on solid resin dispersion AR555, it has about 50 minutes working time, and for top coat with liquid epoxy resin, we have working time about 90 minutes.
Okay. The next question comes from Teresa, and it says, in one of the slides you talked about primer and can be coated in high thickness. Why is it an important feature?
It's a unique feature for waterborne system, because the waterborne, as we know, that you need to get rid of water. Water need to evaporate. So a lot of waterborne system, when you coat a higher thickness, actually it does not dry properly. Either doesn't dry, takes much longer to dry, or actually it cracks. So with Anquamine 728 system, we can coat a high thickness. For example, if a customer prefer to coat at higher thickness, they can just do it in one pass. So definitely would save our time, improve productivity. And typically a lot of customer would prefer to use like a thinner coat, but this is just like an added feature that you can actually do that. So that eliminate like 2 coats or a mid coat.
Okay.
I hope that answers your question. Yeah.
The next question comes from Cody, and it says, can the primer formulation also be used as the top coat? And do you have any starting point formulations?
Yes, The primer can be used, the formulation can be used as a top coat to actually get even faster dry speed. The reason we have this system primer using solid resin dispersion and top coat as liquid using liquid epoxy just to cut down the cost, and then you still meet the requirement for 1-day flooring. But definitely you can use the primer solid resin dispersion for top coat, and we do have our starting point formulations.
Great. The next question says, what is the overcoat window for Anquamine 728 with
So
AR555?
we have looked at the over coatability in lab, like up to 1 week. So we did 2 hour, 1 day, 1 week. The over coatability to epoxy and waterborne urethane are fine. We didn't go beyond 1 week. So I can't say what the issue will work like for more than a week. We just haven't tested that.
Okay, we've got a question from Roberto. How is the surface tension to eliminate the orange peel look, and can you use an additional catalyst?
Yes. Well, I'm just trying to phrase the how I should answer the question. So yes, you can use more catalyst, try to accelerate, but often most of the accelerator actually will ruin your UV stability. And you can add to eliminate the orange peel, you can add additive.
Okay, we've got a couple questions asking about how the comparing to other products. How does it compare to Anquamine? I'm sorry, I'm not pronouncing that. Anquamine 287, Anquamine 287 and 721.
Okay, wow, I'm glad people know about our product, Anquamine 287 and 701. So Anquamine 287, it's a great product. It's a penetrating primer, and you can actually coat it ultra low thickness. So a ultra low thickness, say between 15 to 20% solid. It dries very, very fast within couple hours. So if you want a thin coating of primer, yes, you can use 287. Referring to Anquamine 701. 701 does not dry as fast as Anquamine 728. So it dries more like 7-8 hours at 10 C and 60% or humidity. So for 1-day flooring, it does not meet the requirement.
Okay, maybe I should ask the question again, because the question from Joseph asks the yellowing resistance compared to Anquamine 721.
Oh, okay. So the yellowing resistant, we did do the benchmark, so they are very comparable.
Okay, we've got one. Go ahead.
Anquamine, Anquamine 728, it's a much faster version of compared to 721. So if you are happy with the speed, cure speed of 721, you're good to go. But if you want a faster curing agent, then 728, it's the one to go.
Great. So we have one last question from Gabriel, and it asks, can the primer be used as a moisture barrier coating? And if so, is there any permanence data that you can share?
For the waterborne system, it can be used as a moisture vapor mitigation layer, but so which means it's breathable. Actually, the moisture will permeate. We don't have any data, but just based on the chemistry, we we think it's not a barrier layer, it's a breathable layer, and we don't have any data on it. So if you want a moisture vapor barrier, we do have a product that's specifically designed for excellent moisture barrier properties. And then actually, I'll be presenting at the waterborne symposium.
Great. Well, if there are questions that we didn't get to, we will be able to provide answers in follow up. We want to thank everyone for attending today's webinar. And just as a reminder, we will send you the link to the recording of today's event so that you can watch it anytime and share it with others at your company. This concludes our webinar. Thank you again for attending and have a great day.